let us talk about matrices today. Basically, what are the basic operations involving matrices and what is the significance of matrices? We'll cover these two aspects today. So basically, what is a matrix? A matrix is basically a specific representation of values or variables or functions, etc. Okay, for example, I will take usually whatever I'm telling here, these are called the elements of the matrix. For example, I will specify one matrix for you here: 1 2 3 4. This is also a matrix, usually represented by a closed square brackets. Okay. These are called the elements of the matrix. Usually the elements of the matrix are arranged in terms of rows and columns. Here in this case, there are two number of rows and two number of columns. Here the number of rows are 2 and the number of columns are 2. So the number of rows by number of columns is called the size of a matrix. Whenever we refer a matrix, we use capital English letters like A, B, etc. to denote the matrix. For example, this can be written as A is equal to 1, 2, 3, 4, arranged in terms of 2 rows and 2 columns. I already mentioned these are all called, this 1, 2, 3, 4 is called the elements of the matrix A, and the size is denoted as a suffix to the letter A. So size is here 2 by 2. Okay, another examples we can write. For example, one more thing can be consisting of 4 variables A, B, C, D. I have used 4 different variables for the matrix. For example, another matrix can be f of x or x square, y square, x, y, z. This is one of the matrix. If you see, the size of this matrix ABCD here is again 2 rows and 2 columns. Here again the size of this is 2 rows but it has 3 columns. Okay, so again here the elements are f of x, x square, y square, each is an element of the matrix. Now what is the position of an element? The position of an element is defined by its row to which the element belongs and the column to which it belongs to. For example, in this case, the element 1 belongs to the row 1 and it belongs to the row 1 and column 1. So the position is defined as position 1 1. Okay, position 1 1. Similarly, what would be the position of this element 2 here? It belongs to the first row and second column, so the position here is 1 2. Similarly, what is the position of 3 here? It belongs to the second row but first column, so that is position is 2 1. Similarly, what is the position of the 4 here? That belongs to the second row and second column, so the position is 2 2. So an element at position 2 2 in this case is D, an element at position 1 2 in this case is B, an element at position, say suppose 1 3 is y square here, so its position is position 1 3, since it belongs to the first row but the third column. Okay, so as you see here, there are different kinds of matrices. Here the size of this is 2 by 2, here the size of this is 2 by 3. Similarly, there can be different matrices where the size varies. So in each of the case, sometimes the rows and the number of rows and the number of columns are equal. Okay, in such case the matrix is called a square matrix. In this case, if you see, then it is a square matrix. Why? Because the number of rows is equal to number of columns. Why it was named in that? It is very clear. It appears to be a square. Similarly, in this case, it is called, where number of rows is different from the number of columns, it is called a rectangular matrix. Okay, where number of rows is not equal to number of columns. There can be different types of a matrices. Okay, for example, some other examples I will write. Say suppose here is a matrix where it has only one row, 1 0 2. This is a matrix where it has only one row. Such kind of a matrix which has only rows, the number of columns can be different. In this case, how many number of columns are there here? 1 2 and 3. So its size is 1 by 3. For example, another can be 1 and 2. This size is only one row but 2 columns, it can be 1 by 2. Another example can be A, B, C, D. This is 1 by 4. Okay, this kind of a matrices are called row matrix, which has only one row with them. Number of columns are different. Row matrix or matrices. For example, there are some other kind of a matrices where they will have only one column. Okay, I'll just write it here. For example, they say suppose two variables x and y. This, if you observe, it has only one column but two elements, two rows. Okay, so the size is 2 by 1. Another column can be A, B, C. Here it has 3 rows but one column. Such kind of a matrix are called column matrices. Okay, also sometimes they are referred as column vectors. Okay, usually in 2D coordinate system or 3D coordinate system, whenever you are representing a points in 2D coordinate system or 3D coordinate system, okay, this 2 by 1 matrix is used to represent points in 2D coordinate system. This 3 by 1 matrix is used to represent points in 3D coordinate system. Okay. This is analogous to points in 2D coordinate system. I'll write coord system. Okay. Similarly, this kind of a matrix are used to represent points in 3D coordinate system. Okay. So for example, if I give you one matrix, say suppose this is 2 1. What does it actually mean in a 2D coordinate system? It means the x coordinate of that particular point is 2 while the y coordinate of that particular point is 1. For example, I give you one more right here, 0 1 minus 1. Here the x coordinate, the first one refers to the x coordinate, second one refers to the y coordinate, third element refers to the z coordinate. For example, this 2D coordinates, some I can represent here. Say suppose this is 1 2 3, 1 2 3, 1 2 1 2. Okay, this is being positive x-axis, this is being positive y-axis, opposite of which is negative x-axis and negative y-axis. Okay, so now this 2 1 corresponds to what? This particular point. Okay, say suppose some other points, say suppose this one, this corresponds to 1 3 is the point that can be represented as a single vector 1 3 in this fashion. So the single column vectors are used to represent the corresponding points, corresponding coordinates of the points in 2D coordinate system or 3D coordinate system based on the size of the matrix. Okay. Similarly, there can be other type of matrices also, like for example, say there is a matrix which has all zeros, 0 0 0, or this one, or this one, or this one. These are all of different dimensions, different sizes, 2 by 2. This is 1 by 2. This is 3 by 1, this is 1 by 1. All these matrices whose each element is 0, such kind of a matrices are called null matrix. So null matrix is the one which has zeros as its elements. Each of the element of a null matrix is 0. Similarly, there can be another matrix, another type of matrix are there where non-zero elements are present. Okay, in this I'll tell you one thing in this. For example, if you consider this matrix, here if you see the position of this is 1 1, the position of this element is 1 2, the position of this element is 2 1, the position of this element is 2 2. In each of this, the elements which are present along this 1 1, 2 2, 3 3, for example, one example I'll write here, 1 0 2 3 minus 1 3 0 4 5. Say suppose this is a 3 by 3 matrix, where if you see this position is 1 1, this element minus 1 position is 2 2, and the element 5 position is 3 3. Okay, these elements are called, this is called the diagonal of the matrix, and the element present in the along the diagonal are called diagonal elements of the matrix since it represents a diagonal in a square or a rectangular. Okay, so there will be some kind of a matrices where non-zero elements are present only along the diagonal. For example, 1 0 0, 0 1 0, 0 0 3. Here if you see, this particular matrix has zeros everywhere else except along the diagonal. This kind of a zeros everywhere else except along the diagonal. Okay, this kind of a matrix are called diagonal matrices. Okay, similarly, there can be another example wherein all the elements above the diagonal are 0. For example, 1 0 0, 2 3 0, 5 7 8. This is a matrix where if you see, this is the diagonal, the elements above which every single element is 0, such kind of a matrix is called lower triangular matrix, because only below the diagonal non-zero elements are present, but all the elements above the diagonal is 0. Such kind of a elements are called, such kind of a matrix is called lower triangular matrix. Similarly, there can be another matrix example, where I'll just write one example, where 1 2 3 0 5 6 0 0 8. Okay, in this matrix if you see, this is the diagonal elements. So all the elements below the diagonal are 0. Only above the diagonal non-zero elements are present. Such kind of a matrix is called upper triangular matrix. Okay, so we saw different kinds of matrices now. Square matrix, I'll just write down one by one. Square matrix and rectangular matrix based on the size of the matrices, where both are defined in terms of number of rows and number of columns. If the number of rows and number of columns are equal, it is called square matrix. If they are different, it is called rectangular matrix. Then we saw row matrix and column matrix. In row matrix, only one row will be present. Similarly, in column matrix, only one column will be present. So this column matrix is also sometimes called column vector, which is used to represent which is used to represent points in that corresponding coordinate system. For example, a column matrix has 2 rows. It is used to represent 2D coordinate system, points in 2D coordinate system. And for example, if the column vector has 3 rows, it is used to represent 3D points in 3D coordinate system. Similarly, we saw null matrix. Null matrix is the one where every element of the matrix is 0. It can be of any size, but each and every element of the matrix is 0. And similarly, we have seen diagonal matrix, where only elements present across the diagonal, every other element other than the diagonal is 0, and how the position of the matrix is being defined, that also we saw. For example, position say Ij, an element's position say Ij, I corresponds to the row to which it belongs, and J corresponds to the column to which it belongs. Okay, so what is diagonal elements we saw, and diagonal matrix, where other than diagonal every other element is 0, and lower triangular matrix, where above the triangle all elements are 0, upper triangular matrix, where below the diagonal all elements are 0. These are basically the different types of matrices.